In this example, we will anti-differentiate 1 over the square root of e to the x minus 1. So looking at the integrand, no method or technique of integration is jumping out at me. So going through our list, there is no obvious algebraic simplification, no obvious substitution. The integral does not fit any of the standard forms. So the next thing is, would there be a more subtle substitution? And this substitution is quite subtle. If you look at our integrand, you notice that we want to pick u typically to be something inside another function. Well, you have e to the x minus 1 inside the square root, but you have the entire quantity square root e to the x minus 1 inside the denominator. So I'm going to go ahead and try u equals the square root of e to the x minus 1. And in order to work with this conveniently, I'm going to manipulate it a little bit and say that this would imply that u squared is e to the x minus 1. So now differentiating, in terms of differentials, 2u du is equal to e to the x dx. And this is going to allow us to take our integrand and write it solely in terms of the variable u. So in the integrand, the entire denominator is going to be u, but we need to express that dx in terms of u. So what I can do is think about maybe taking this e to the x term and dividing it off to the other side. But when I do that, I need to put it in terms of u's. So we know that u squared is equal to e to the x minus 1. So e to the x is equal to u squared plus 1, which tells us that dx will be equal to 2u over u squared plus 1 du. So this is definitely a much more difficult and more subtle substitution than we are maybe used to, but it's a good problem to think about. So now our antiderivative, the integrand itself, becomes 1 over u, and then cutting and pasting over here our dx, we will have 2u over u squared plus 1. And now this turns out to be a very reasonable integral to evaluate. The u's cancel, 2 is a constant that can be pulled out front, and you're left anti-differentiating the quantity 1 over u squared plus 1. And that's simply arctangent of u, and then plus our constant c. So the real difficulty here ended up being kind of just getting started. Once we made that first step, the antiderivative that resulted was extremely reasonable. And let's go ahead and finish by putting it back in terms of x. So u is the square root of e to the x minus 1, and we have our solution.